one thing we can predict, if we know the position of an element in the periodic table, is roughly its size. Or better said, we can predict whether it's going to be larger or smaller than another atom. And that is because atomic volume, the size of an atom, is a periodic property. There are two things that kind of influence the way the size of an atom. On one hand, the number of electrons you have determines the size. It kind of stands to reason that if you have a hydrogen that has only one proton and one electron, that's going to be much smaller than if you have francium here that has a whopping 87 electrons in the electronic cloud and 87 protons. So on one hand, you have that the higher the atomic number, the more electrons you've got, the more stuff you have to fit in that atom, so the larger the atom should be. On the other hand, you have the fact that every time you increase the atomic number, you are adding one proton in the nucleus and one electron in the electronic cloud, and that proton goes in a place where it's a very, very small space, which is packed with positive charges. And think again, the football field and the marble in the middle, and the marble is your nucleus. So you're adding positive charges, protons, in a place where you already have positive charges in a very small space. That makes that positive charge, very powerful because it's very concentrated. And it has the ability to attract electrons around them, even some of them further away, quite more strongly than if it wasn't that concentrated. There are electrons in the middle, in between your very strong concentrated positive charge and the electron you are adding in the electronic cloud. There are all these electrons in the middle that are kind of shielding your electron further away from the nucleus. But in general, but they don't all do the same type of good shielding. S, P, D, F orbitals, they have different ability to interfere with the strength of that positive charge attracting the electrons. So that means that you expect an atom to be larger because it has a higher mass number, so it should has more electrons, has more stuff, and actually you find out that it's not as large as you would expect it, because you have a very powerful positive charge attracting the electrons in the outer shell. So those two aspects conflict when you determine when you're looking at the size of an atom. So which one is more important? And the answer is, it depends if you're looking at a period or if you're looking at a group. So when you are looking at a particular group, the atoms in the same group, you have, because you move from one energy level to the next, the fact that you have more stuff that occupies more space wins. So the smallest atoms in a group are always at the top. So hydrogen is because it has one electron and one proton, is much smaller than francium that has 87 electrons and 87 protons. However, when you go across the period, you are in the same energy level, then it is the fact that you have a more powerful positive charge that wins. And actually you will see that fluorine, which has 9 electrons and 9 protons, is smaller than oxygen that only has 8 electrons and 8 protons. Because even if there is one extra electron to accommodate in fluorine that there isn't in oxygen, the nucleus has gained one proton, and it's a very concentrated and powerful positive charge that attracts that extra electrons. So the atom is not as large as you would expect it to be. This is called Scandic and lanthanide contractions. If you want to read about this, or if you want to continue reading about this, so you are not particularly happy with this more sort of generic explanation. So the small, except hydrogen, which is the smallest atom at all, and as I told you, is not precisely, it's difficult to allocate hydrogen depending on its properties. The smallest atoms of the periodic table are on this corner. So fluorine, helium, oxygen. And the largest atoms of the periodic table are on this corner. Francium is accredited with it being the largest atom of the whole periodic table. So again, the further you move towards the left in a period, the larger the atoms become. The further you go down into a group, the larger the atoms become. And that is because of these two conflicting things, the fact that you have the strongest you get your positive charge, the more it attracts the electrons and the atom shrinks. And on the other hand, you've got if you have more electrons, they're going to occupy more space. And those two conflicting things that influence atomic volume behave like that in the periodic table, and that is one of the reasons why the periodic table is established like that, and why fluorine is next to oxygen and has neon on the other side, and at the bottom it has chlorine.